Hello everyone. Can you hear my voice? Okay, okay. Good evening. So, do all of you know which subject we are going to learn today? I mean, in this class? Can one of you reply or in the chat box? So, which subject we are dealing with? Yeah. So, we'll be dealing with geotechnical subject, geotechnical engineering. Yeah, that is topic index properties. But see, I may not follow that index properties, but I'll update in the every class what I'm going to teach in the next class. Okay, sometimes we may not reach whatever I have told in the website. So we'll be starting with the introduction of the soil and what are the major parameters which we use throughout this class, all these things. So I just want to know how many of you have attended previous round of NPTEL gate sessions. So can you reply in the chat box how many of you have attended already? I can see some uh, new names this time. Electrical engineering. Who is that? Neelam Saroj? You can leave. Okay, okay, okay. So we'll be starting. We'll be learning new things also in this class. If you have not attended, Neelam Saroj, if you are not from this civil engineering department, uh, you can leave, but it is up to you. You can stay also if you want to learn few things from civil. Yeah, yeah, that's okay. So I hope there are significant number of students who are new to this class. So we will start with the introduction of the students first. In which year you are? Are you in B Tech or M Tech or just preparing for GATE IES? So I just want to know. So one by one you can start with. So I'll just announce the name, then you can start with your introduction. You just have to tell your year of study. Okay, okay, I will ask. I will ask by name. You can tell that time. Okay. I don't know who is this. Anyway, Prajwal. Prajwal, can you hear me? Yes, yes. Okay. What about Santosh? Which year, Prajwal? Which year you are in? Okay, fine. Santosh. Santosh G. What about Ajay? Okay, fine. Okay, okay, no. Okay, nice, nice. Amruta? Yes. Good evening. Oh, nice, nice. Okay, okay. Thank you. Acha, acha. Okay, no issues. uh, Vani and Babita. Chaudhary, Ajay. See, if anybody is from second year BTech, you please let me know, because few of you are not responding. I just want to know if anybody is there from the second year BTech or second year BE. Otherwise, I consider at least you have some knowledge in this soil mechanics or foundation engineering. Okay, so I hope this is fine. So I'm considering every one of you are above third year, are equal to third year. I mean, so if you are in third year, you must have completed first semester. So you might have heard about soil mechanics in your first semester. If I am no, so in which year you are in? Sai, right? BTech third year. Yes. So there is no soil mechanics subject in your first semester of third year. It is there, right? Okay. So that is what I wanted to know. Just you have heard something. Okay. So we can start the class. I hope everybody can see the slide presentation. You can confirm by voice. Yeah, yeah. Fine. As this is the first class, I'll introduce. There are many students who are from third year also. So I'll just go through uh, important parameters of soil mechanics, which will be used in entire foundation engineering and soil mechanics. So this generally soil is a material which is in unconsolidated stage, initial stage, when we get outside, and it comprises of solid particles, very tiny solid particles. So when is what is soil? When these solid tiny particles are together, then a solid mass, you can tell, which has air inside it as well as the solid particles. It may be containing some water. So all these combining, we say it is a soil. So whichever deals with the engineering part of the soil, that comes under soil mechanics. So this soil mechanics, this was taken by this word or this mechanics is introduced by a researcher uh, who is who is also called as father of soil mechanics, is Dr. Carl Terjargi. He has introduced this word soil mechanics in 1925. Okay, this is just rough introduction about the soil or soil mechanics. So what do we deal with in the soil mechanics? So we need to know how is it useful for the engineering purpose. So you are constructing your all structures on the earth. Earth is nothing but it is having soil on its surface. So it should be able to take all the load from the structure. Structure contains many other loads, and there are some dynamic loads from the vehicles, earthquake, whatever. So all these loads should be taken by at the end soil. So this uh, if you know the engineering properties and how does it take the load, how much, what is the capacity, so does it need any extra provisions to give some capacity, or alone soil alone has some capacity. All these things will come to know in the upcoming classes. So for the time being, so I'll start with, so I'll make some imaginary diagrams. So but before that I'll have to go for some realistic diagram also. So let us say, see, this is ground level, let us say. This is ground level. So below the ground level, everywhere there is soil. There is structure above the ground. Okay, there is structure above the ground. Now this, if I zoom in the particles, soil particles, then okay, they may not be exactly round. So like this. Okay, I just zoomed in all this. Now if I make a, I'll just take some part. Okay, these are what? These are solid soil particles. These are solids, you can say. Okay, then wherever there is a gap, so you take cricket balls. So if you try to arrange in any container, okay, take a container, you just arrange them. Okay, there is another small ball, you can say. See, there is always gap. There is always gap forms, right? This is gap. The red color is, let us say, gap. You cannot fill this gap with another ball or another particle. So every, if you put together all the solid particles, it has some voids in it. These are called voids, this gap. So this is void, nothing but gap. Okay, and this black color, these are solids. Now I'll just pour some water. Okay, so I'll pour some water from the top. What will happen? The water goes inside from here, then it tries to settle in the gaps. Okay, in the gaps. Fine. Now another thing is, if you pour sufficient water from the top, then all the voids will be filled by this water. If you are not pouring the sufficient water, what will happen? Some voids will be half filled, some voids will be fully filled, some voids will be maybe completely empty. So let us take, call it as average. So all voids may be full with water. That is one condition if you pour sufficient. And another one is, if you do not pour sufficient water, it's not pouring water, it may be coming from the rain. Outside, if you take the field, it is coming from the rain. So then what happens? The voids may be partially filled. Okay, the voids may be partially filled, one condition. Another condition is, all the voids may be filled with water. And third condition is, there is no water, let us say, it's completely dry. Okay, in summer, the top part of the soil, if you take the top part of the soil in summer, it may be completely dry, you may not find any water moisture in it. So then all the voids may be empty. All voids may be filled with, filled with air. Okay, so there are three conditions. like this. Fully voids, I'm talking about only voids. There is always solid present in the soil mass. If you take any mass without solid particles, you cannot say it is soil mass. So one is solids, and second one is water and or air. Okay, there will be solids and there will be water and air, or there will be only water, there will be only air, and that these two will be there in the voids. Okay, these two will be there in the voids. Now by using this concept, we can make a three-phase diagram, which we call three-phase diagram. Three-phase diagram. So see, this is rectangle. Just taking a rectangle. Okay, so there will be always soil solids. So I'll dedicate this volume to the solids. Okay, this is, let us say, volume of solids, and remaining, if it is, this total will be the soil mass. Okay, this is total V. Just V is total volume of soil, right? So the soil generally present in this form, right? Suppose if you take in any bowl like this, there will be voids inside, and solid particles are just arranged in different direction. But here what I'm taking, what I'm I'm bringing all these solid particles in this imaginary box. Okay, there is no void present in this portion, so that is called volume of solids, and total will be total volume V, and remaining will be what? Volume of voids. I told you, one is solids, another one is voids. These voids may be filled with water and or air. Okay. Now what do I do? I'll just divide these voids into two parts. One part is, so this one is solids and this one is water. Okay, and this will be air. So this again, if I draw this volume of water, volume of air. So as there can be three different materials present in the soil mass, this is called three-phase diagram. Okay. Now just a minute. So now by this we can understand that if there are three things, solids are there, solids will be anyway there always. There will be water and let us say air. Two things are there. Now that means voids are not fully filled with water. There is some air left in every void. You can say average. So that is the reason why it is not, whenever all the voids are filled with water completely, that is called saturated. So it's a general term. Generally, we might have heard this. A saturated condition means if it is voids are completely filled with water. Okay, if it is not completely filled with water, if some air is left, that is called partially saturated. Partially saturated. Okay, and if all the voids are filled with water, then you can say fully saturated. See, sometimes terminology is like that. People may not mention fully. They may mention saturated, just saturated. Then also it is taken as fully saturated. If it is specifically mentioned partially saturated, then only there is some air in it. And third one is dry soil. When do you call dry soil? Generally, if there is no water, that means only air. And fourth one is frozen soil. So that is generally we don't deal with those kind of frozen soils in the geotechnical engineering subject. The frozen soil is having ice in it, okay, along with water, air, solids, extra ice will be there along with all these things. So now going back to uh, yeah, total volume is V, and total volume is nothing but volume of solids plus volume of voids, right? And volume of solids plus volume of voids again divided into 2, that is volume of air plus volume of water, right? Now partially saturated, in that case volume of voids is nothing but volume of air plus volume of water. What about fully saturated? If I take fully saturated soil, volume of voids is nothing but volume of water, right? Because there is no air in it, because it is fully saturated, so total voids will be equal to total water. Then dry soil, dry soil will be volume of voids will be volume of air. There will not be no, there will not be any water. So this is how you should remember. Vs means solids, it's not soil. Just V means total soil, okay? And Vv is voids, Va is volume of air, Vw is volume of water, okay? So we'll learn some parameters, some terminology you should be aware of. Let us start with void ratio, okay, which is denoted by E. It is ratio of volume of voids to the volume of solids. This is defined as ratio of volume of voids to the volume of solids, okay? This is the ratio, this is the formula, okay? This is not derivation. The next, so if let us try to see the range. Can volume of voids be 0? Can anybody reply? Volume of voids, can that be 0? Is this possible? No. There will always be some void. That is the reason why it cannot be 0. It is always positive, right? And secondly, if it is more than 100% or not, that we will check. Okay, now we understood that it is greater than 0 always. Okay, it is greater than 0. Whether it is, if you multiply by 100, let us say, actually this is not the definition. Definition is just ratio. If I want to calculate the percentage, let us say VV by VS into 100, or else you can say, you can take the 1, okay? Whether it is greater than 1 or not, let us check. For it to be greater than 1, the VV should be greater than solids. So can it happen volume of voids are greater than volume of solids? Can somebody reply? volume of voids can be greater than volume of solids, or should it be less than? It can be. How? Can you modify your sentence? Or else you can just tell that can you have a control over volume of voids? It can be less than, it can be greater than, or it can be equal. So do you have any control? Can you modify your sentence? I'm just asking, do you have any control over volume of voids? Mm. Yeah, depending upon the arrangement of the solid particles. So we don't have any control over these voids, right? They are formed automatically. So there can be a structure which is forming like this because of the attracting forces between the solid particles. So it can stand like this where there is a big void in it. But totally, if you see, there is void portion more. So in that case, volume of voids can be greater than volume of solids. It can be less than. It can be anything. So you cannot say that it is less than one. So in that case, you can write only is greater than 0. Okay, you cannot write the upper range. Then another parameter comes porosity, which is denoted by small n. So it is defined as ratio between volume of voids to the total volume. Now this is the definition. You cannot have any doubt on this. Why is this definition like that? The definition is like that. Then later derivation will be all the different kinds of derivations and engineering mechanics. Everything will be dependent upon this definitions. Fine. Now I hope you can tell me the range in between which the n falls. Can somebody tell me the range? Can VV be more than V? Volume of voids greater than total volume of the soil. Is this possible? No. So it can be equal to, equal means just less than that. Okay. That means it is always less than 1. Okay. Now n is here. What about the minimum? Volume of voids will be 0. It cannot be 0. So it will be always greater than 0. So like that. This is the range. And then degree of saturation. Degree of saturation, which is denoted by S, simply S, or SR. R is suffix. Okay. So this, the definition is, it's the ratio between volume of water to the volume of voids. Okay. Generally it is uh, expressed in terms of percentage. So you can write this. Now tell me how, if you are expressing in terms of percentage, then in between which two values it should follow? It should fall. Please remember when you are expressing something in terms of percentage. So what is the by default range? It's a common sense question. 0 to 100. So that means, see, it is dealing with only volume of voids, not total volume, right? So total volume of voids can be total water, then it can be 100%. The volume of water can be 0 in the dry soil. So volume of water can be 0. So it can range in between 0 to 100. So, and one more thing, if something is expressed in the percentage, there is no other choice beyond 100 percentage, right? So that should be in between 0 to 100. And the fourth one is air content, which is denoted by AC, A suffix C. So this definition is volume of air to the volume of voids. Okay, so it also falls in the 0 to 1 or 0 to 100 because volume of air can be 0 because total voids can be water, and then total voids can be filled with air, then it is 1. That is how it is. It can be in between 0 to 1 or 0 to 100 if it is percentage. Then percentage air voids. Another parameter is percentage air voids, which is denoted by n suffix a, defined as volume of air by total volume into 100. The name itself is having percentage. Okay. So then can you tell me in between which it is undefined? I'll tell you why. Okay, later. So then water content. See, these are very, very important. This may be very small definitions now, but this will become very important because you might forget what is there in the denominator. If you forget what is there in the denominator, then everything will change in your big problems. Okay, if you are given to calculate the volume of the total soil which is required to fill in the embankment. Suppose if you take instead of porosity, if you take void ratio, then you may take one meter cube soil instead of 5 meter cube. So everything will change. You have to remember this always. Right? Degree of saturation. It deals with only volume of voids. These may be simple in so coming to the water content, this is the major parameter in soil mechanics. This is the ratio of water, weight of the water to the weight of the solids. It is small w. Okay, it is expressed in percentage. Weight of water to the weight of solids. Okay, only solids. That means dry soil. So if you multiply with 100, then you will get percentage. This is how water content. This is also called as moisture content. Okay. Now we'll be entering into unit weights. Okay. Now unit weights of soil. Okay. One is bulk unit weight. So another one is saturated unit weight, and it can be dry unit weight. Another thing is not related to the soil completely. That will be related to the solids. That I'll tell in the next slide. Just a minute. So bulk unit weight means the unit weight. What is the definition of unit weight? Can somebody tell me? So unit weight, if you denote it by gamma, so that is weight by total volume, right? So this weight contains weight of the solids plus weight of the water. Is there any weight from the air? No, so that's why I don't give that here. So only, even though there is air, we don't take it. If it might have some weight, actually we have studied in our school life, there is some weight, but we'll neglect that. We'll assume air doesn't have any weight. Okay, so the total weight divided by total volume. So as this is dealing with the bulk, see, bulk always will be used for the current state. Okay, it might be dry, it might be saturated, whatever, but you have to use this for the current state. It may be saturated, but it is still bulk. It may be dry, it is still bulk. But people use generally bulk unit weight when there is partially saturated conditions, then only people use bulk. Mostly, you can say that means there is some water in it, there is some void in it. Sorry, some air in it. Coming to the saturated unit weight, again, see, this is denoted by gamma B, and saturated unit weight denoted by gamma SAT. Again, it is also W by V, weight of the soil divided by the volume of the soil. This weight of the soil, this is weight of the soil. If there is no suffix, that means it is soil, complete soil. It has solids, water, everything. Okay, and that's why I'm not mentioning. Anyway, for your ease of understanding, I'll make it soil. Okay. In this, weight of soil has, I can write weight of air also here, but it is anyway zero later. So in this, it has only weight of solids plus weight of water. It doesn't have any air in it. So that condition is called saturated unit weight. Okay. Now, if you take the same soil sample, can you tell me which one will be greater out of these two? Gamma B or gamma sat? Which is greater? Gamma D. Somebody has messaged maybe. Can you tell me which one is greater out of these two? Gamma B or gamma sat? Same soil sample, same volume. Same soil sample means same volume. I'm just taking here. So in this box, one is fully saturated, one is partially saturated. Now I just want to know what is bulk unit weight, what is saturated unit weight. So you are saying this gamma sat is less than. That means gamma B is greater. Okay, fine. Equal is fine. How can it be greater? Can you explain? Hmm. Equal nahi. See, gamma bulk means partially saturated. There is no, it's not that all voids are filled with water, total voids. Still, there is some air. So, if there is still some air, so weight of the solids are same. This is also same. Weight of water will be more in case of saturated unit weight. In case of saturated condition, so always gamma sat will be greater than gamma bulk. Okay, what about dry unit weight? Again, weight of the soil and volume of the soil. So in this, weight of the soil will be equal to weight of the solids, because weight of water is zero, because there is no water. That's why it is called dry unit weight. So now, can you tell me gamma D and relationship between gamma D and gamma sat and gamma bulk? Where should I keep this gamma D? Should I keep right side of this gamma bulk in this, or this direction, or this direction, or in between these two? Where should I keep? I'll just gamma. bulk and gamma sat and gamma dry. Okay, can you arrange these in ascending or descending order in terms of uh, magnitude? 1 minute. Gamma, okay, greater than dry. This one you are telling about? Yes, correct. Because see, if you see weight of water, weight of soil, weight of soil, weight of soil, divided by total volume of soil. Now this is same for all these things. Weight of soil is different because here weight of soil has weight of solids plus weight of water, full water. Here also weight of solids is there, but water is partial. Okay, here only weight of solids. That's how the order is. The another thing is unit weight, that is unit weight of solids, unit weight of only solids, that is denoted by gamma s. See, whenever there is s, that is nothing but solids, only solids. So this is weight of solids by volume of solids. See, we are not talking about the soil here. We are not talking about the soil. We are talking, suppose you just take unit weight of rubber. What do? You will take weight of the rubber and volume of the rubber. Okay, just like that. I am talking about the solids, just solids. Then you have to take weight of the solids divided by the volume of the solids. Okay, we are not talking about the soil to take volume of soil. These are related to the volume of soil. Unit fully saturated unit weight of the soil, bulk unit weight of the soil, dry unit weight of the soil. Whereas this is not unit weight of the soil, this is unit weight of the solid. That is the reason why you have to use volume of solids here. Okay, this is what. And another one is, the major thing is specific gravity of solids. Specific gravity of solids. Okay, that is denoted by G. That G is written as, solids means you have to take the unit weight of the solids and unit weight of the water. See, specific gravity of any material is, what is the definition which we know from our school level? The unit weight of that material or density of that material divided by density of water. In the same way here, unit weight of solid, specific gravity of solids means unit weight of the solids divided by unit weight of water. Now, just specific gravity is also nothing but specific gravity of solids. You cannot take specific gravity means specific gravity of soil. Okay, by default, specific gravity means it deals with only solids. And in our soil mechanics, wherever we use specific gravity, which is denoted by G, that is nothing but always specific gravity of solids, not soil. So if you want to know what is the specific gravity of soil mass, okay, mass, specific gravity of soil, like that, then that is nothing but what? G is again gamma by gamma W, where gamma is gamma bulk, it can be gamma bulk, it can be gamma saturated, it can be gamma dry, it can be anything. But we don't use this. If somebody is saying specific gravity of soil, even though if some people are saying specific gravity of soil, that means still it is this only. It is not at all this one. You should always take gamma solids by gamma W. Please remember this. Now we'll derive It's one relationship. There will be some important relationships. Yeah. See, there will be some important relationships that I will. Yeah. Tell me. Tell me. Okay. This one. No, you should calculate gamma solids. How to calculate weight of solids plus by divided by volume of solids. You cannot take any total volume or like that. To find to find out G, you need to use gamma solids, not gamma soil. Okay, no gamma bulk, no gamma saturation, or no gamma dry. You have to use only these things. Okay, yeah. Coming back to the important relationships which we use in our soil mechanics. See, let us first go with the water content. So water content is denoted by small w, which is nothing but weight of water, right, divided by weight of solids. So this is what the definition of the water content. Okay, this is what the definition of water content. Now, what do I do? I'll just write. See, any weight. How, what can you write? Volume into density. You can write volume into density. So I'll write volume of water into density of water. See, any volume of material, if it is multiplied with the density of the material, the same material, you will get the weight of the material. So weight of the water, right? Now, weight of solids. Here also I will do the same. Volume of solids multiplied by density of the solids. Density is denoted by rho. This is rho density, and this is gamma. This is unit weight. What is the relationship between these two? Gamma is rho g. That's it. Okay. It is acceleration, gravitational force. Okay. And then now you have converted this weight of water, weight of this is the definition. You cannot question here. This is definition. Then after that, I'm using all my knowledge how to elaborate it. Okay. Now also another thing we know what is uh, uh, degree of saturation. Yes, sir. See, what is the degree of saturation? Degree of saturation means we are talking about the water content, right? Water, like the level of water. How to find out the level of water? If you compare with the volume of voids, total volume of water, then you can tell whether it is fully saturated or whether it is partially saturated. So that's the thing. So now what did I take? SR equal to volume of water divided by volume of voids, right? So I'm talking percentage. I'm not taking. I'm taking in between 0 and 1 right now. So now I can use volume of water, then SR into VV, right? Volume of water left side, then SR into VV. Now keeping this aside, what is G? Specific gravity of soil or solids, it is same. That is density of solids. Okay, you can say density or unit weight. If you take unit weight here at this place and at this place, you take unit weight here. If you take density, you take density. It is all same. It is just difference is just this. Okay, so what is that? G is density of solids divided by density of water. So this is the definition. Now I can convert again density of solids into density of G into density of water, right? Now can you substitute these values? See, in place of VW you put these two here, in place of rho s you put these two. So what this equation 1? equation 1 will become in place SR into VV divided by Vs into rho s. In place of rho s, you put G and this. So this both will be cancelled. So then what is left? What is left? S VV G Vs, right? S R VV by Vs into G. What is this? VV divided by Vs? We have studied just now. VV divided by Vs, that is void ratio. Okay, that is void ratio. Now SR void ratio you can write. So finally, W equal to SRE by G. You can write WG equal to ESR. So this is one relationship. Here W is not in terms of percentage, remember, because we did not multiply anywhere 100. If you multiply 100, then only percentage. If you don't multiply, you have to take in the normal values, not in percentages. So G of the soil, water content of the soil, void ratio of the soil, then saturation, the saturation level of the soil. This is one relationship. Like this, you can derive many other relationships between different parameters of the soil. So this is one of the relationships. So you can go through any standard textbook that A.K. Arora or Gopal Ranjan, where you can find all the derivations, but you have to find out, you have to remember the formulas directly, not derivations. Derivations, definitely you know, you should know the derivation, but you should be having this on your fingertips, then only you can attempt easily in the gate exam. Okay, there are many other relationships. Okay, anyway, as we have derived this relationship, the we will solve one problem regarding this. Okay, so the question is from civil engineering gate 2009 paper. So this, the marks for this question is 2 marks. Okay, this question number is 59. So we'll go through the question first. A saturated undisturbed sample from a clay strata. See, you have to read every single word. You should know what does that mean. Saturated means fully saturated by default. Okay, undisturbed means sample is not disturbed. Suppose here in the this is ground level, this is field. If you want to collect a sample from this place without disturbing its structure, okay, then they collect that. That sample has, that sample is fully saturated. Okay, that is clay. There is clay, there is sand, there is silty sand or silty clay, different types of soils. Out of them is clay is one of the type of soil. So it has the moisture content. Moisture content means water content, 22.2 percentage. So here I'm saying given data is saturated. Okay, given data, given data. Saturated means what? SR equal to 100 percentage or 1 you can write because fully saturated. Then what is the moisture content? Moisture content is denoted by W. That is 22.22 percentage. That means 0.2222. Right? Specific weight, that is G, is 2.7. Then gamma W, 10 kilonewton per meter cube. So what you have to find out is void ratio, that means E, and saturated unit weight. Saturated unit weight means gamma sat. Okay, so now I have to find out E and I have to find out gamma saturated, right? What are the given things? I have been given water content, I have been given G, I have been given gamma W, gamma of water, also saturation level. This is 0.2222, this is 2.7, this is 10 kilonewton per meter cube, and this one is 100 percentage, that means 1. So by seeing these given values, you should understand how to find out E, because we just have derived Wg equal to ESR. That is the formula which you have to remember, or this is the derivation which we have done just now. So you know this 0.22, G is 2.7, E is unknown, SR is 1. Can you tell me what is the E value? Can you calculate and tell me immediately? 0.59. Can you just tell me what are the other digits? At least three digits, please use at least three decimals. Yes, you have to tell this. Okay, then next. So this is done. We found out this. And what is the next thing? We have to find out saturated unit weight. Okay, saturated unit weight. So I just told you there are another derivations in which you will derive this formula. G plus ESR. This is, sorry, gamma bulk. I'll just gamma bulk. Gamma bulk G plus ESR divided by 1 plus E multiplied by gamma W. Okay, this is gamma bulk. Thinking that it is not fully saturated or dry, whatever, it has some water in it. Now we are asked to find out gamma sat. In gamma saturation condition, SR equal to 1. If SR equal to 1, you can put 1 here. Then formula will become G plus E divided by 1 plus E multiplied by gamma W. See this one. So here, if you see the 0.5999, it is equal to zero point 0.6. We don't have 0.5999 anywhere. We have zero point 0.6. Okay, these two, one of the these two options should be correct. Okay, that's why zero point 0.6 I'm taking here. So if you use zero point 0.6 and G value 2.7 and gamma W 10, can you tell me what is the gamma sat? Because I'm using 1, that's why it is gamma sat. Can you please calculate and tell me, or should I calculate? 20.625 kilonewton per meter cube. Because see, G does not have units, E also does not have units, because they are ratios of equal unit weights. Then the equal units. So here only the units will be equal to units of water. So now go back to the 20.625. So answer is C. So this is how you have to solve the questions. If you know the relationships like this relationship, you can easily solve this. Okay. So I hope you have understood today's class. Do you have any doubts? No. Okay. Can we close the session then? Okay, then we'll meet in the next class next Thursday. I hope you don't have any doubts. So I'll be leaving the meeting. Yeah, fine. Thank you. Thank you, everyone.